Chapter 4.2, Inverse Functions. We often use a pair of functions that are natural opposites of each other. By a natural opposite, we mean that one of the functions undoes the result of the other function, much the same as subtraction undoes the result of addition and division undoes multiplication. Two functions with this relationship are called inverse functions. And we have guidelines for finding the inverse function, which is designated. This is your designated. It's not f raised to the negative 1. That's your designation for f inverse. Guideline number 1. Solve the function y equals fx for x. Let x is equal to f inverse of y. Guideline number 2. Exchange x and y to get y equals f inverse of x. Guideline number 3. Check the domain and ranges. The domain of f and the range of f inverse should be the same, as should the domain of f inverse and the range of f. So let's apply this to a problem. Okay, find the inverse function and then check the range and domain of f and f inverse. So let's find the inverse of fx is equal to 4x minus 5. The first step, let y equals fx equals to 4x minus 5. So this is the original function, fx is equal to 4x minus 5. So we're going to set it to y is equal to the function so that we can solve for x. So the next line, you see that we remove the fx. We just have y is equal to 4x minus 5. And then you solve for x. Y plus 5 is equal to 4x minus 5 plus 5. That's to get rid of the 5. Y plus 5 equals 4x. Now we need to get rid of the 4. So we divide both sides by 4. So we find that x is equal to y plus 5 over 4. So the f inverse y is equal to y plus 5 over 4. So now we just replace, according to the second rule, exchange x and y to get y inverse of x. So we end up with exchanging the y's with the x. So f inverse of x is equal to x plus 5 over 4. So there we have it. Fx is equal to 4x minus 5 is the original function. F inverse of x is equal to x plus 5 over 4. Got it? Set y in the place of fx, solve for x. And once you solve for x, at the end of that, you replace your y with your x. So we solve for x, that's the f inverse of y, and then we replace wherever we see y with an x. So f inverse of x is equal to x plus 5 over 4. Now, according to the third rule, the range of an inverse function is the domain of the original function. So we're using the example fx is equal to 4x minus 5. We found that the f inverse of x is equal to x plus 5 over 4. To test the range and domain, try a value for x. Let's use x is equal to 2, because we know that the domain will be the x values, right? So fx is equal to 4x minus 5. So we're using 2, x equal 2. So wherever we see x, we replace it with a 2. F over 2, f of 2 is equal to 4 times 2 minus 5. So 4 times 2 is 8 minus 5, so f of 2 is equal to 3. Now use your answer, which is 3, to test the f inverse of x. So f inverse of x is equal to x plus 5 over 4, which we found earlier. So wherever you see the x, you replace it with 3 now. So f inverse of 3 is equal to 3 plus 5 over 4, which is equal to 8 over 4. F inverse is equal to 2. So it checks out because we arrive back at the value that we chose for x. the original domain value, which is your x values, we chose 2, right? Use 2, put it into the original function, and we got 3. We took that 3 and put it to the inverse function, and then we arrived back at 2.